A kata is something you practice, not something you watch. Read the lesson, write the code yourself, then review what you wrote. This video is the reference you come back to afterwards. A model can produce this code in seconds, and the reason to write it by hand is to keep the judgment that tells you whether the code is any good. UseEffect is the hook people reach for first and understand last. Most of that is because it gets taught as a lifecycle method with a strange signature, and it is not one. It has a single job: keep something outside React in step with something inside it. The document title, a timer, a subscription, a listener on the window. Once that is the definition, the most useful thing this lesson can tell you is that a large share of the effects in real code bases should not exist at all, and the playground at the end has one of those next to its replacement. A side effect is any work that reaches outside the component. Fetching from an API, starting a timer, subscribing to something, touching the DOM directly, adding a listener. What all of those have in common is that they are not part of producing the output. Rendering is meant to be a calculation. Given this state and these props, return this markup and change nothing else on the way. Effects are where the changing something else goes, and keeping the two apart is what lets React call your component whenever it likes. One detail on screen worth sharpening. Effects do not just run after React updates the DOM, they run after the browser has painted it. So the user sees the new frame first and your effect runs after. That is deliberate, and it is why an effect is the wrong place to measure or adjust layout. Two arguments: a function holding the work and an array. The array is where the confusion lives because it looks like a list of triggers, and it is not. It is a list of values to compare. After every single render, React compares each item against what it was last time, and if they are all the same, it skips the effect. So no array at all means nothing to compare, so it runs every render. An empty array means nothing ever changes, so it runs once. And a populated array means it runs whenever one of those values differs. Same mechanism in all three cases, which is easier to hold on to than three separate rules. The first example writes the count into the browser tab title. This is the shape of a proper effect, a value inside React, a thing outside it, and a line keeping the second in step with the first. The count is in the dependency array, so it runs when the count changes and not otherwise. Watch the tab as you press the button. Nothing about this could be done during render because writing to the document title is exactly the kind of outside world change that render is not allowed to make. An empty dependency array means the comparison never finds a difference, so the effect runs after the first render and never again. This is where setup goes: opening a connection, reading something once, starting a subscription. There is a detail here that catches everybody in development. React's strict mode deliberately mounts your component, unmounts it and mounts it again, so this effect runs twice and your console logs twice. Nothing is broken. It is a test, and what it is testing is whether your cleanup actually undoes your setup. If running the effect twice breaks something, it would also break in production the moment that component remounted. Fix the cleanup rather than fighting the double run. An effect can return a function, and React calls it before running the effect again and once more when the component goes away. That is the cleanup. The timer here is the clearest case. Set an interval on the way in, clear it on the way out. Leave that out, and every remount starts another interval while the old ones keep firing, which is a leak that shows up as a counter that speeds up for no reason. The rule is worth stating as a pair. Anything you start in an effect, stop in its cleanup. Anything you subscribe to, unsubscribe from. Same pattern against the browser window. Add the listener on mount, remove it in the cleanup, and the width on screen tracks the window as you resize it. Two things to notice: the function you pass to add event listener and the one you pass to remove event listener have to be the same reference, or the removal silently does nothing. And the dependency array is empty here, which is only correct because the handler does not close over anything that changes. The moment it reads a piece of state, that state belongs in the array, and then the listener is removed and re-added when it changes. Fetching on mount is the example everybody starts with, and it is the one with the most sharp edges. The effect function itself cannot be isync because React reserves its return value for the cleanup, and an isync function returns a promise. So the isync work goes in an inner function that you call. Beyond that, a fetch needs to handle the response arriving after the component has gone, and two fetches resolving out of order. The next lesson is about cleanup properly, and that is where those get handled. It is also worth saying plainly that for real applications, this is a solved problem. A data library handles caching, retries, and race conditions, and writing it by hand is for understanding, not for production. 4 on screen, and they have one root. Missing dependencies means the effect closes over a value from an old render and quietly uses a stale one. An infinite loop means the effect sets a piece of state that is in its own dependency array, so it runs, changes the thing it watches, and runs again. Forgetting cleanup leaks the timer or the listener, and the effect function cannot be async for the reason we just covered. Turn on the exhaustive dependencies lint rule and let it fill the array in for you. When it demands something you were not expecting, that is usually the rule finding a bug rather than being annoying. An effect synchronizes React with something outside it, and it runs after the browser paints. The dependency array is a comparison, not a trigger list. Cleanup runs before the next effect and on unmount, and anything you start belongs in it. The effect function is never async. And the question to ask before writing one at all is whether the work reaches outside the component. Because if it does not, there is a good chance it should not be an effect. This is the effect that should not exist, and it is extremely common. 3 pieces of state, a first name, a last name, and a full name. An effect watches the first two and sets the third to the two joined together. It works. It is also wrong in 3 separate ways. There is a piece of state holding something that was already derivable from other state. So now there are 2 sources for one fact. Every keystroke costs an extra render because React renders with the new first name, then runs the effect, then the setter schedules another render. And in between those 2 renders, the full name on screen is the previous one, so the value is briefly stale. Read the note in the middle of the preview. It says exactly that, and you can watch it happen. The fix removes code. The third piece of state is gone, the effect is gone, and the full name is a plain constant computed in the body of the component. 1 render per keystroke, no stale window, 1 source of truth. The reason this is safe is the thing worth taking away. Rendering is a function call, and recomputing a value during render is what render is for. If a value can be calculated from state and props you already have, calculate it. Reach for an effect only when the calculation is genuinely expensive, and even then the answer is a memo rather than a piece of state. The last variant is the other half of the argument because none of this means effects are bad. 3 pieces of state and 2 effects, and both of them earn their place. The first writes the count into the document title, which is an external system that React knows nothing about. The second runs an interval while the timer is running, and returns a cleanup that clears it, so nothing is left behind when it stops or when the component goes away. Read the 2 together and the test becomes concrete. Is this effect keeping something outside React in step with something inside it? These 2 are. The one in the first variant was not. The model to keep is a single question. Does this reach outside the component? A timer, a subscription, the document title, a listener on the window, those are outside and they need an effect and a cleanup that undoes it. A value computed from state you already hold is not outside, and it needs a line of arithmetic during render. Most of the use effect confusion people carry around comes from using it for the second thing, and the fix there is not a better effect, it is no effect. The kata is the part that matters. Open the lesson, write the code yourself, then read back what you wrote and judge it. The link is in the description, and that practice is what keeps the skill yours.